Good afternoon, everyone, or good evening if you are in the United States or Americas. As you may have noticed, this is our first webinar after a long break. So in July, we had a very successful summer school for quantitative history at Shanghai Jiao Tong University, which lasted for 9 days. We also had the International Symposium on Quantitative History there. It was a very exciting period with an overdose of new ideas and exciting research. So now we are back to our Quantitative History webinar series again. As I just mentioned, this is our first episode. And today we are very happy to have Professor Andrea Matranga, who is an assistant professor of economics at Chapman University in California. Professor Matranga is someone whose research I've been following for a number of years. So today he's going to present his many years of work on the origin or the invention of agriculture at 7 different locations around the earth over a span of 7,000 years. I know for a fact this question of why the 7 different regions independently and without communication with each other invented and adopted sedentary agriculture. This question has been intriguing to him throughout his career, I guess, since college, even to this day. And also his work has played a big role in inspiring my own interest in this big question, even though we try to rely on more specifically archaeological data from China. So we really look forward to this exciting talk. Just very quickly, by way of background, Professor Matranga got his PhD in economic history from Universitat Pompeu in Barcelona, Spain.
Pompeu Fabra.
Yeah, okay, so he can say it more appropriately in Spanish. And then after he got his PhD, he spent several years at the New Economic School in Moscow. And then last year he switched from Moscow, from the New Economic School in Moscow to Chapman University. Andrea, so you take it over from here.
Absolutely.
Oh, by the way, quickly, so today we have as our invited discussant, my colleague, Jed Kaplan, who is a professor of earth science at the University of Hong Kong. So he will give a discussion for about 10 minutes. And then after his discussion, we will open up to Q&As from everyone in attendance. And then if you have any questions like in the past, please post your questions in the chat room. Okay, so Andrea, sorry for the interruption.
Absolutely. So yes, thank you for the introduction, and thank you for inviting me to begin with. So the paper is called "The Ant and the Grasshopper," which it refers to the story in Aesop's fables of the ant that is during the whole summer is harvesting seeds and storing them in the burrow so that it has something to eat in the winter, while the grasshopper is singing. And then in winter, the ant has something to eat and the grasshopper doesn't. And what I argue is that this interplay of seasonality and storage is crucial for understanding the multiple adoption of invention of agriculture and domestication, and then its spread throughout the world. So what we're talking about is the Neolithic Revolution, which is, this is just to sort of fix some ideas. And so the idea is that, since way before our species even existed, since, hominid times, our ancestors have lived as hunter-gatherers, which is what you see in the top panel, which means that they are exclusively or almost exclusively eating foods that are naturally produced by the environment. And they hunt the wild animals, they gather the wild plants. And typically when people hear hunter-gatherers, they tend to focus on the hunting much more than the gathering, but they were at least equal in most cases. And in most cases, actually, most of the calories were actually coming from plants, and so from the gatherers. And the other important thing about hunter-gatherers is that almost, well, not exclusively, but most commonly, they are nomadic, which means that they move from place to place, usually not every day, usually not every night, perhaps a few times a month to a few times a year. They pick up everything, or they abandon their dwellings. They move to some other place which has better hunting or better plant foods, and they create a new settlement. Well, it's not a settlement, but a new camp there. They exploit the resources until they have, they're starting to run low again, and perhaps the game has moved off because they were scared off by the constant hunting, and then they repeat this. And instead, with farming, with the Neolithic, what you have is no longer are you just exclusively relying on naturally occurring food, but you're expending labor. You can see the labor both in the background. They're perhaps planting something, and also the harvesting is the same, but the planting is what makes the difference. They are planting food, and they're expending effort in order to increase the amount of food that the landscape is able to provide. And just as important as the food production is the fact that to do so, they become sedentary. So those are houses that are not abandoned commonly. They might be passed on from generation to generation. They might be rebuilt every so often, but they're not abandoned constantly. And this is almost as important, and in some sense more important than the actual increase in the amount of food produced. And we'll see why in the presentation. So why is the Neolithic important? Well, obviously it's important because there's more food, and this allows for an increase in population density. And this means that there's both larger, each group, each sort of population is larger, but also there are more such groups living in a given area. So this means there can be more trade, and there can be more exchange of goods and ideas. And obviously it would be very hard to have fast technological progress if there's only a few hundred people or a few tens of thousands of people populating, for example, the continent of Europe. It's a lot easier, and you get more progress the more people you have. Now, the second thing is that it allowed for sedentarism. And sedentarism is important because it allows for greater social control. It's easier to keep tabs on people that are sedentary. And it also allows you to have technology which is heavier than what you can carry. So if you think about kilns, if you think about smelting ovens, so for producing metals, these are all very massive technology that requires a lot of time to prepare, at least to make it efficient. You can prepare it in some rudimentary fashion, but to make it efficient, it has to be pretty big. And these are things that it's just impossible to do if you're constantly moving around chasing animals. You're probably not going to hit on this. And you're also not going to hit on the idea of building fortifications. And fortifications are important, of course, because they're sort of important for political structures and who's inside the fortification, who's outside of the fortification. It's effectively, let's say, instantaneous political capital, or it's a way to transform a temporary military advantage into a lasting one through fortifications. And it's something that is not available to nomads. And then what really is important about the agriculture is that it's a portable model. So you could think of other things that increase the amount of food. Somebody could invent fishing nets or harpoons, or perhaps implements for grinding or for trapping animals. But these are all things that, while they would have the same effect in terms of increasing the amount of food, they tend to not be as portable. So for example, in the Pacific Northwest, so the area of Washington State and British Columbia, there were very important groups of Native Americans that trapped salmons during the salmon run. And they had developed, sedentarism and multi-level societies with complex hierarchies and complex material cultures. But this was a model that could not be replicated anywhere else because, there was no way for them to harness the salmon and move to another place. Not so with the seed. Once you've domesticated the plant, once you have that precious wheat or rice or flax or millet, you can take that seed with you and you can move to another place, chop down the forest and start growing it there. It's as if it's a franchisable model, we could say, in the sense that you can replicate it in other places. And that's what makes agriculture so important. It's not just that it was more food, it was that it was more food. It was a technology for producing more food, which you could replicate almost anywhere you had water and sunlight and reasonable weather parameters. There was some plant that you could domesticate and move with it. And so the Neolithic is also mysterious besides being important. And why is it mysterious? There's 4 questions which I'll be trying to answer, and I would like you to evaluate. Obviously, it's a bit cheeky to ask you to pick my own evaluation mechanism, but I think a good way to evaluate this presentation is whether I'm successful in answering these questions. And the first one is, why didn't agriculture appear sooner? Because humans, biologically modern humans, had been around for maybe 150,000, maybe 200,000 years, in which time, as far as we know, there was no agriculture. And then we see it happen in 7 places. This is question number 2. Why did it appear in multiple locations at once? Because there's about 7 places that adopt agriculture within a span of about 5,000 years. So if you compare that to the 200,000 years in which no agriculture had happened, then 5,000 years isn't really that long. And then the question is, well, why these locations? Why not others? So what did all of these locations have in common that caused this similar adoption of some technologies and associated social practices? And then the final question is why is it that farmers tend to be shorter than the hunter-gatherers that preceded them? In some places up to 10 centimeters, such as in the Middle East. And you wouldn't necessarily expect this. You would expect this that if you do something, it's because perhaps you're eating more, and if you're eating more, you should be taller. And now the further sort of issue that we also have to thread the needle is that the theory has to be sufficiently specific to account for these broad similarities: the domestication of crops, the adoption of sedentism, the sort of eventually they progress to civilizations. But also, we have to be sufficiently flexible to allow for the specificities. For example, if I were to say that the reason that agriculture was invented was because there was wild wheat in the Middle East, though that's not a good theory, because in South America, they did it without wild wheat. In fact, they did it without any cereals at all. They did it with potatoes and squashes. And they didn't have any cereal crops in South America. They did have it in Central and North America, of course. So it couldn't be that. So it has to be sufficiently specific to account for the similarities between all of these places, and yet sufficiently flexible to allow for all of these specificities. And there was a lot of proposed explanation, and so far, none of them has been entirely consistent with the evidence. In fact, there's a paper by Gremillon, Barton, and Piperno in 2014 which advocated effectively, or rather they described a retreat from theory, which is this idea that, that perhaps we were hubristic in this attempt to explain the Neolithic. Perhaps this was a fool's errand, because actually these are completely different processes, and we shouldn't be sort of geographically deterministic and think that, there was just one reason why this happened in all of these places. These are completely different phenomena that happen in different places. They have some superficial similarities, but maybe we're just trying too hard to find a common explanation for these, while actually these are distinct phenomena. And again, this is a viable thing. It's easy what I think it's called pareidolia, which is when you're looking at things and you see shapes in the clouds where really there's nothing. It's a risk that we have to guard. We should all guard against as scientists, and I hope this isn't what happens here, but I'm looking for the question and answer session, what your impressions are. Okay, so these are the places where it was invented. There's about, as I said, there's 7 of them. There's 3 in the Americas. There's Oaxaca in Mexico. There's Eastern North America, and there is some regions that later became the Incas in South America. And then the oldest one is in the Middle East. It's actually not the it's not the Mesopotamia, it's the Fertile Crescent, which is the area of hills and mountains, the Zagros and is it the Taurus mountain? I hope so. In Syria, Turkey, Israel, it's that whole area that sort of borders the Fertile Crescent. And then also in sub-Saharan Africa, in the Sahel region, it was also invented agriculture, and 2 almost simultaneous inventions in China. Now, these are all, as far as the consensus opinion is that these are independent inventions. Somebody might suspect, well, why is it that, why is it that China accounts for 2? How do they know that it's not 1? And the basic idea is that these are different crops that are domesticated, and now they grow each other's crops as well. So you would expect that if they were getting this through cultural movement or perhaps demographic movement, then they would move with the first crop domesticated and then perhaps domesticate others. They wouldn't move to a new place and immediately domesticate a new crop and abandon the one that they already had. So this is the reason, at least this is how it was explained to me, for why North and South China are considered 2 different domestication events. Okay, so the first theory could be, well, what if it was just, population growth? And what if it was just, people move to an area, initially there's very few people, and then the population grows, and eventually there's too many people to feed, and so you have to start farming. So there's too many people to feed through hunting and gathering, so you have to start farming. And the problem with that theory is that, again, people had been in the Sahel, in sub-Saharan Africa, for about 200,000 years. And instead in South America, some people say only since 20,000 years ago, some people say 30,000. But in any case, a much shorter period of time. And yet, they all adopted agriculture within this relatively narrow period that goes from about 11,000 years ago to about 4,000 years ago. So it doesn't seem to be just something that's waiting to happen, because if that was the case, then it would have first happened in Africa, then the Middle East, and then we would expect the North China and South China, and only then the Americas, and instead we get effectively a fairly random, in fact, the last adoption was in Africa, which was the first place where people started from. And instead, what I argue is the dominant effect, and really, I think the only explanation for why all of these places would adopt simultaneously, given that there was no contact between them directly of people moving around, it has to be something that has to have to do with climate, because it's the only thing that they all share. And specifically, reading a little bit about this, I found this out about Milankovitch cycles, which are cycles in the tilt of Earth's axis, which determines the season and some other more subtle effects. And these determine the amount of seasonality in Earth's climate. And so you see that around the time when this happened, it was actually a peak in seasonality. Not an absolute peak, but nonetheless a peak within, let's say, the last, pretty much the last 90,000 years. This was the highest amount of seasonality in the Northern Hemisphere, which is where most of the Earth's landmass is. And I argue that this is why it happened. And so how can we explain this? Basically, when there is an increase in seasonality, it's not so much that food becomes scarce in general, but it becomes scarce at a specific time in very large areas, such large that it's impossible to out-migrate. So for example, food is scarce in all of Europe, unless you're a stork, it's going to be very hard for you to move to Africa. And so what happens is that, if you're a nomad, you're not able to find food anywhere within a reasonable yearly migratory range. And yet there's a lot of food in the summer, but there's no food in the winter. So an obvious solution to this is to start storing food. If you have access to a food that stores reasonably well, you can dig a hole, you can put it in a cave, you can weave a basket, and you can fill it up with food while it's there to be had. And then you can consume this food during the winter. But to do this, you have to become sedentary. It's impossible to carry enough food to last you through a winter. In fact, even with the most freeze-dried, extreme energy dense foods that, for example, special forces use in armies, it's really hard to carry more than about 2 weeks of food with you. And if you also have kids, it's impossible to carry several months worth of food. So you can become sedentary, but to do so, you can store food, but to do so, you have to become sedentary. And now once you're sedentary and you already know how to store food, effectively you're pre-adapted for the invention of agriculture. Because if you're nomadic, you're in a bit of a chicken and egg problem where it's really hard to become sedentary. There's no reason to become sedentary if you're a hunter-gatherer. In fact, you want to remain nomadic so that you can chase the animals. But how are you going to learn how to farm if you're always moving around? So the way to solve this problem is to first become sedentary, and you become sedentary just to store the wild food. And then once you're sedentary and you know how to store food, then agriculture becomes almost an inevitability in a sense, because it just means you're being a little bit more careful to, not let the animals eat those foods that you rely on, that you're going to rely on, in the summer to gather them so that you have them in the winter. And so then perhaps you do a little bit of irrigation. Maybe you do some check dams in a valley, let the water sort of accumulate a little bit. Maybe you do some diversion, and then eventually you can progress to more intensive forms of agriculture. And so the important thing about this is that the transition is going to be optimal for a rational population. This is only important for economists, but I'm an economist, so if you can explain something with a rational population, and it's going to be at equilibrium. What this means, it's not like, there was a sudden decrease, there was a sudden famine, and people started to farm, because the traditional response to a sudden famine is not to invent something new really quickly, a life-changing, strategy. Typically what happens is, unfortunately, that they actually do starve. And then after that, there's very few people left, and they have no incentive to start farming because now, there's a ton of game, things have recovered, and there's very few people. While the advantage of this theory is that it works in equilibrium. Even if nothing is changing from year to year, there's this constant alternation between summer, winter, and as the leaves grow red, or as it can also be between a dry and a wet season, but let's say in winter, as this leaves go red, you start worrying and you start wondering, what if there could be a way of avoiding this starvation? And storage is a very simple and effective way of eliminating it pretty much entirely. Okay, so again, what happens, just to summarize, you have this increase in solar and the seasonality of solar radiation, and this strengthens the monsoon, and the changes in temperature seasonality and the changes in precipitation seasonality means there's a more seasonal food supply, and this makes storage attractive, which makes sedentism necessary, and both of these things make cultivation more likely. And eventually this progresses to domestication. And once you have domesticated the crops, then this leads to geographic spread. And what this means is, and it's also going to be faster, the more seasonality there is, the faster the spread. In fact, it could very well be that there's agriculture that we know nothing about that was happening at very low possibility. Every once in a while, somebody would invent agriculture on a hilltop, and they would do it for a few generations, and then it would die out. We have no way of knowing this. What we know about what we call the discovery of agriculture is that this is agriculture which spread. This is agriculture which was sufficiently useful and sufficiently successful that either the populations that did it were able to maybe perhaps capture land from their neighbors, or their neighbors wanted to copy them. When we say the invention of agriculture, what we should really say is the spread of agriculture. And actually, I was talking to Jed before, and I came up with a new analogy, which is it's similar to saying, why are there wildfires? Well, you could say this wildfire started because somebody threw a match, or this wildfire started because of a lightning. But you really have to think about what are the conditions, such as dry, warm weather, wind, which make it so that the kind of spark that would have died in a nothingness, in a wetter period, cause enormous damage in wildfires. Well, in this case with the Neolithic, you have to think, why is it that once somebody had this idea, it spread so fast? I think it's because, of this seasonality. Okay, so what is it that creates a seasonality? There's basically three different changes. One of them is that Earth's axis gets more tilted and less tilted over time. And then the other one is that the orbit gets more or less eccentric, meaning that it gets more or less elliptical. Sometimes it's more circular and sometimes it's more elliptical. And then the other one, which is actually probably the dominant one, is the precession of the equinoxes. And that it changes which hemisphere is pointed towards the sun when we are closest to the sun. So for example, right now, I think most of the people listening to this are going to be in the northern hemisphere. We are in the northern hemisphere summer, which means that the North Pole is tilted towards the sun. We're here, right? We're tilted towards the sun, but we're also further away from the sun because of this is how the way the shape of Earth's orbit is now. So this means that our summers are slightly cooler than they would otherwise be. And our winters are slightly warmer because when we're tilted away from the sun, we're also closer to the sun. And it's the opposite in the southern hemisphere. Now, what happened 12,000 years ago, around the time when agriculture started, was that these cycles were asynchronous, meaning that the eccentricity of the orbit was pretty high, meaning that the orbit was fairly elliptical. And also the precession was such that the northern hemisphere was tilted towards the Earth when we were closer to the sun. So the two sources of seasonality were actually summing instead of subtracting the way they are now. And this meant that 12,000 years ago, seasonality in the northern hemisphere was at its highest level for about the previous 100,000 years. So it was an exceptionally seasonal period in Earth's history, at least since humans had left Africa. So that's sort of why this period. Okay, and I have data for the last 22,000 years of climate. And what you can see is that about around 16,000 and sort of peaking 11,000 years ago, there's an increase in the number of cells that are in the 95th percentile of seasonality. And then the other thing that you can see is that, in the 99th percentile of seasonality, there's very few of them. There's none actually during the Ice Age. And then as the Milankovitch cycles come into synchronous, then you get this peak in the number of very seasonal places. And the other thing you can see is that the places that are very seasonal adopted agriculture soon, and the places that adopted agriculture late are the ones that were unseasonal. Okay, this is just sort of stylized facts to say, does it explain the broad pattern of which places invented agriculture and when they invented it? And yes, it does. It does as good as anything, just in terms of observation, in terms of correlation. I'm not claiming that these are causal, but does it answer those questions? And I think it does. Okay, we can also look at a specific case. This is the Natufians, which is the population that eventually developed agriculture. It became the pre-pottery Neolithic A and pre-pottery Neolithic B that then developed agriculture. And what you can see is that they were living in exceptionally seasonal times, in an exceptionally seasonal place, because you have all of these species they're relying on for food. And then there's this gap between January and March when pretty much all of their sources of food are not available. And my argument is that this is why they started to store food. In fact, the Natufians, they're not farming, but they're already storing food. And the reason they're doing this is because they need to somehow remain alive through December, January, February, and early March. And this is the idea. And then once they become sedentary, that's when they start farming. And you can see, yeah, so these are all the different sources of food. Okay, so there's a lot of related literature on this. There's literature that has looked at the Neolithic triggers. So why is it that agriculture started? Some people have argued it's gradual population growth. Some people argue it was warmer climates. Some people argue it was drier climates. Some people argue it was more stable climates, less stable climates, or intermediately stable climates. So basically, these are all differences in either the conditions that are on average or the variation from one decade or from one century to the other. Well, the difference is that in my theory, we're arguing what's really dominant is the predictable variation between summer and winter or between dry and wet season. And then the other question is, why is it that people became shorter? And one answer is it could be that, Diamond's theory is that it was man's worst mistake. He says, people started to farm thinking they have more food, but then when they become sedentary, they also start having more kids. And then the problem with that is you get runaway population growth and you end up worse off than you started. Or it could be that they had to devote a lot of resources to defense because they'd become sedentary and become sitting ducks. Or maybe they were investing in non-food goods, or maybe their elites forced them to take farming, or once they were farming, they were able to extract their surplus because they knew where they lived, so it was easier to tax them. And then there's also literature on the long run effects of the Neolithic on its gradual spread, on the idea that it started, places that started farming had earlier state formation and had a head start, or perhaps the fact that they could accumulate technology, fixed capital, that there was greater farming productivity, which in fact continues to this day. Not necessarily the specific places, but if you look at the largest crops today, they tend to be the earliest ones. And the reason is it's probably not that the plants were so special in terms of their long run potential, but there's so much learning by doing, and there's so much selection for varieties that whichever crops you start farming 12,000 years ago, if you keep doing it generation over generation of parasite resistance and selecting for higher yield, eventually you get, modern rice, modern wheat, which are just fantastic, phenomenal plants in terms of what you're able to get out of them from a given amount of land, water, and sunshine. Okay, so I'm going to go really quickly over the model. I'm just going to explain what it is that it does, what the assumptions are and what it does. And then I'm going to talk about the empirics. And basically, there are four strands of evidence that I'm going to bring to the table. And the first one is, it's sort of, it's going to be about, can we show that places that had higher seasonality are more likely to invent agriculture? And then we're going to show that places that have more seasonality were faster in adopting agriculture. And then these are together two subpoints of climate and the Neolithic. And then we're going to look at geographic variety. So we're going to look at whether it's possible to diversify your risk geographically. And does that make adoption of agriculture faster or slower? And then we're also going to look at the evidence for whether there was an increase or decrease in consumption seasonality across the transition. Okay, so the idea of the model is that there are two environments. There's the hill and the valley, and there's 2 months, July and December. And the idea is that in the hill, you get a certain amount of food. You get 1 plus sigma. Sigma is your seasonality parameter. So you get 1 plus sigma in the summer, and you get 1 minus sigma in December. And in the valley, you don't get any food in July because it's too hot and dry. But in December, you get a little bit more food than what you get in the hill. And so the options you have are become sedentary and remain here and store sigma amount of food in July so that you can consume it in winter. And so in this case, you would consume 1 unit of food in both months, or you can be nomadic, in which case you're going to consume in the hill in July and then move to the valley in December. And how are you going to make that decision? It's going to depend on your utility function, which is just, log of your consumption per capita in July and your consumption per capita in December. That's all your utility is. Effectively, it's a Cobb-Douglas, but it's easier to do it as logs. Okay, and so the important thing is that nomadism and storage are mutually exclusive. Either you're nomadic and you go back and forth, but then you can't store food, or you are settled and then you can store food, but then you lose access to this gamma amount of extra food you could have had if you were nomadic. And there's a population is assumed to be constant. There's an endogenous population growth in the paper. It doesn't really change a lot. There's some subtle points that are interesting, but it's fine for the paper. We don't need it in this presentation. Okay, so this is what the model looks like. You have December consumption and July consumption, and in the hill, you have 1 plus sigma and 1 minus sigma. And so this is where you would be if there was no seasonality, but you do have seasonality. So this is where you are in the hill. And then if you instead go to the valley, then you have no food in July, but you have quite a bit more food in this gamma extra amount of food in December. And so if you are settled, you can store food. You can store this amount of food. Sorry, could somebody tell me, can you see my cursor at all? Could somebody answer me in the chat? Like if I move this, can you see it or?
Yes, it's fine.
Okay, perfect. Thank you. Because otherwise this was going to be tricky. So starting off in the hill, I consume a certain amount of food and then I store a certain amount of food and then I consume it in summer. And so I can get back to the 0 seasonality line. And instead, if I'm nomadic, then I can get the best of both environments, but I can't store food. Now, which one of these is going to be better is going to depend on the utility function and how seasonal the environment is. In this case, it's not so seasonal, so you're actually better off being a nomad. But if you were in a different situation where it was more seasonal and the gamma, the geographic ability to diversify, is not so strong, then now the utility of being a nomad is lower than that of being a settler, and everybody switches. And the important thing is that when you do so, you have less food in total because you lost this gamma amount of food. If you notice, you have a higher utility, but this is actually on a higher, you have more food. The sum of these two amounts of food is higher than this one. So this is why you become shorter, because you're abandoning some dispersed food sources. That's the theory. Even though you're happier, it's not a mistake. It's like insurance. You're happy to pay a premium. You know that on average you're losing money, but you just want to get rid of that volatility. It's perfectly reasonable, especially if that's what your kids are eating. That's what you want to insure. I think it's a very reasonable thing for people to do today, and it was reasonable to do it 12,000 years as well. So what are the predictions of the model? You have that climate seasonality should make the invention of agriculture more likely, and it should also make it spread faster, right? Because the more seasonal the climate, the higher the utility of becoming settled is. And as we said, becoming settled means that eventually you're going to probably start farming, or at least it makes it a lot easier. And it's also going to make it easier for it to spread. Now, there's also, if you have a presence of uncorrelated food sources, for example, let's say you live close to a coastline, so you have access to fish, shellfish, that sort of thing, then this should delay adoption, right? Because the bigger gamma is, as gamma becomes big, meaning that there's uncorrelated food sources, at some point, nomadism is higher utility than being settled. So this is an independent axis. One of them is how seasonal the environment is. The other one is how much variation is there locally. So if you think about being in the middle of the Great Plains in the US, probably not a lot of variation. Well, if you're in the foothills of the Himalayas, then, just moving 10, 50 kilometers completely changes the biome you're in and means that you're going to have access to uncorrelated food sources. And then the third prediction is that when transitioning to farming, consumption per capita should drop both in the short run. Remember, you're losing this amount of food. When you move from here to here, you actually have less food on average. And there's also a demographic effect, which is that when you remove seasonality, the amount of food you need to survive decreases, which means that population will increase and consumption per capita decreases. And then finally, ideally, when you observe that transition to farming, there should be a consumption seasonality, should decrease substantially, right? Because that was your payoff, was that as a hunter-gatherer, you eat a lot in summer and then you starve yourself during the winter and you hope to make it, like polar bears, basically. While as a settled farmer, then you should be able to smooth your consumption, like a squirrel or like the ants sort of storing seeds. And so you shouldn't have these big swings in consumption seasonality. And these are all predictions that we can test econometrically, and I do so in this paper. Okay, so just in terms of does this model hold water we have to speed up a little bit. So does this model hold water in terms of, the 7 places that invented agriculture? I had a postdoc in archaeology do the research for me so that I wouldn't be sort of biased because it's my theory. And so I asked them, for each of these places, answer me 4 questions. Look at all the literature and ask, is it true that seasonality increased before agriculture appears? Yes or no? And then, is it true that there's an intermediate phase in which people are sedentary, and this happens before you see agriculture? They're already sedentary, but they're still hunter-gatherers. Yes or no? And then, do we observe that people are sedentary before or during when we observe storage? Yes or no? And then, is it true that we observe storage before you observe agriculture? And the ones are where the prediction is confirmed. The zeros are where it isn't. And in terms of the seasonality increase before agriculture, yes, this happens in 7 out of 7 of them. The other ones, they happen in 5 out of 7, and different ones happen in different different ones. Different places have fail or not. But obviously the archaeological record is not entirely complete. So obviously it could be that I'm incorrect, but it could also be these are sort of novel predictions. So the fact that all in all, let's say 80% of them are in fact correct is I think a reasonably good benchmark given the sort of gaps in the historical record, in the archaeological record. Okay, so what are my data sources? So I have data on invention, on domestication events, in fact, from Purugana and Fuller. It's a Nature paper. There's 7 sites that adopted agriculture and 17 other that are domestication sites, but it's unknown if there are, it's unclear whether they are independent or not. And then we have data on adoption from Putterman and Trainer. We have 160 countries and the date he adopted. And then we have climate data from Feng He at the University of Wisconsin, and he has 48, it's a grid of 48 times 96 cells times 22,000 years. And we collapse this to 44 periods of 500 years, sorry. And then we also have data from Western Eurasia, which are 765 archaeological sites that have been carbon dated for the earliest adoption of agriculture. And here I'm using modern data, which are averages from 1950 to 2000, because this data, it doesn't have enough resolution to resolve these, the differences in the European data. And then there's some controls, altitude, distance from the sea, latitude, and the Americas dummy, that sort of thing. Okay, okay, I'm just going to, so I have 2 measures of seasonality that I'm going to focus on. I'm going to skip seasonality index. So there's temperature seasonality. That's the difference between the warmest month in the year and the coldest month in the year, censored at 0. And the idea of this is that if you have 30 degrees Celsius in summer and 0 in winter, that is an environment that has a lot of variation in the amount of food that you're going to get. But if you have minus 20 in summer and minus 50 in winter, it's still a 30-degree difference, but it's just frozen all the time. So we're only interested in the proportion, the variation in temperature, which is above freezing, because once things freeze, nothing is growing and it doesn't super matter what happens after that. And then in terms of precipitation seasonality, I'm using the precipitation during the wettest year minus the precipitation during the wettest month minus the precipitation during the driest month divided by the mean precipitation. So why am I using this and not the same? Well, if I just use the subtraction, the problem is that there might be a place that has 5 meters of water during 1 month and 2 meters of water during another month. And that sounds like a big difference in the absolute terms, but in practice, it's underwater all the time. So it's not at all dry. And so that's not great. And if I instead just did the ratio, then what happens is that some places it just doesn't rain during the dry season, and then it goes to infinity because I'm dividing by 0. And so I didn't want that either. This is sort of like attractive properties because it doesn't sort of go to one extreme or the other as it sort of stays within a reasonable set. Okay, and then so the first question is, these are the places that invented agriculture, are the dots. And what you see is the pink squares are the places that were seasonal 21,000 years ago. And then the red ones are 8,000 years ago. And what you can see, first of all, is just that there's an explosion in the number of places that are seasonal because there's a lot more red than there is pink. And then the other thing is that these places that invented agriculture are either on or very close to these very seasonal places. Okay, so I'm just going to skip to the data. So what we have here is the year in which agriculture was adopted. And you have, you see that temperature seasonality, each extra Celsius degree of temperature seasonality brings back the date of adoption by between 110 and 130 years, or if we put geographic fixed effects, these are sort of neighborhood fixed effects, about 60 years. And so what this means is that if you have 10 degrees more difference in this temperature seasonality measure, it brings back the adoption of agriculture in a specific place between 600 and 1300 years. And for precipitation seasonality, you have a similar well, I mean, the precipitation seasonality, the measure is smaller, so the beta coefficients are similar, but each, if it increases by 1, it brings back the date between 500 and 900 years. And this is with controls. If you put controls for temperature averages, if you put an absolute latitude controls, if you put the altitude and the distance from the sea, and if you put geographic fixed effects, you get pretty much the same impact. So what this shows is that the more seasonal a place is, the earlier they adopt agriculture. Okay, and then instead, if we just look at invention, this is a logit model of invention, and which, this is very hard because it's a data set which has only 7 ones in the times and places where agriculture was invented. And then everything else, so there's 1,032 cells times 44 periods, there's 38,000 in totals. I drop places as they adopt agriculture. So there's only 7 ones in the sea of zeros, but you still see that temperature seasonality is a strong predictor of agriculture. Okay, and then we can look at the spread of agriculture. So we can ask, did agriculture spread faster once it was invented? Did the neighbor adopts faster if they were themselves very seasonal? Okay, and so what I'm going to do is I'm going to drop all of the observations that are either completely inhospitable, meaning they're really dry or really cold. Effectively, the hard deserts, the Gobi Desert, the Sahara Desert, and the Australian deserts, and also the places that are very, very cold, such as the Himalayas or the Arctic. And then I also drop them. It's a panel data set, and I keep dropping places as they adopt agriculture. So we're focusing on places that have reasonable climate and are within 500 kilometers of a place that has already adopted agriculture. It's kind of like a contagion model, or maybe you could imagine if we were modeling a fire, we're looking at places that are already next to a fire and have, they're not they're completely underwater or have complete lack of fuel. That would be if you want to keep the fire analogy. And then we're looking at how fast does agriculture spread to these places based on whether they are based on whether they are seasonal or not. Okay, so what this looks like is, 11,500 years ago, there is a little green dot. I can zoom in. There's a little green dot, which is where they invented agriculture. And then these places are within 500 kilometers, and therefore they are at risk. And so these places are in the data set with a 0. And then as time goes on, it spreads. So I drop those I give them a 1. And then in the next period, I drop them because they already invented, and now there's new places that are at risk. And then eventually, for example, in the Andes, it also starts, and then also in China, it arrives. So now there's new places that are at risk of adopting agriculture. So only the red areas are in the data set, and they're only in the data set for the one period in which they adopted agriculture. Okay. And they are only in it, they're only in it once agriculture arrives close, and then they have a 0, and then when they adopt it, they have a 1, and then, okay, sorry, and then okay, I need to zoom out, but it's not letting me zoom out. I'm gonna share my screen again. And there we go. Okay. So first they're not in the data set. Then, somebody invents it and they're in the data set with a 0. They stay in the data set with a 0 as long as they don't adopt agriculture. Then when they adopt agriculture, they have a 1, and then I drop them forever. So this is my contagion model for the spread of the Neolithic. And what we have is that if the temperature seasonality is close to the bottom of the distribution, this is like the 1 standard deviation below the average, then you have this risk of adopting. And if instead you have 1 standard deviation above, the average, then you have this other curve. And one way you can see it, one way we can quantify the difference is that if you look at 2,000 years after agriculture arrives to a neighborhood, if you have a high temperature seasonality, there's a 40% chance, if you have a low temperature seasonality, there's a 40% chance that you're still farming, I will get this right. So if the temperature seasonality is low, then you have a 40% chance that you're still hunting 2,000 years later. And if the temperature seasonality is high, then you have, let's call this 25% chance of still farming. And we get similar results for the precipitation. So both of these, we already saw that it makes it more likely that you invent agriculture, but it also makes it spread faster, which is another prediction of my model. Okay, and then we can also do this with the regression. Again, we're using linear regression, and then also with a logit. And what you see is that temperature seasonality is a pretty good prediction, even after we introduce, geographic clustering, and precipitation seasonality. These are local clusters. I think there are 80 clusters. These are little squares that I ran, it's a grid of neighboring cells that I cluster. And so both temperature seasonality and precipitation seasonality predict the spread of agriculture. Okay, we can also look at Europe. Oh, am I supposed to? So I'm finishing at 10. Somebody can do the answer? Or at 10:03, what was it?
Yes. Oh, no. We're going to finish at 10:30. So we have
yes, so I finish at 10. Yes.
Finish at 10, yes.
Yes, perfect. So you can also do this with these 765. So you can also do this with these 7. What happened? yeah, 765 sites in Europe. And what you can see is that it's not true that it's Fertile Crescent. If we look at fertility, which is this right stuff, this is the Fertile Crescent. It is there, but it's no more fertile than most of the northern coast of the Mediterranean. What it has is that it's the one place that is both super fertile and super seasonal. And this is why it starts here. And then I also do, if we look at sort of temperature difference and precipitation seasonality, so temperature seasonality and precipitation seasonality, you can see that the ones that have the higher seasonality adopted soon, and then the ones that had the lower seasonality adopted later. And this is also true controlling for distance from the first place that did agriculture. Okay, and then this is a sort of orthogonal way of checking stuff. Remember we talked about geographic variation. If there's a lot of geographic variation, then you can exploit that geographic variation either nomadically or perhaps even as a sedentary person, even as a settler. If you're really living at the edge of the Grand Canyon, then even as a settler, you can sort of go at the bottom of the canyon or at the top of the canyon and have different environments. And so the idea is if you have a lot of variation within 5 kilometers, then it makes sense to become a settler because you can exploit that variation even by being a settler. While if you have a lot of variation, which is within a 50-kilometer radius, that is too much to exploit from one location. So you're going to want to move from this hill to that hill in order to exploit that variation. And so the way I measure this, let's take the case of these 4 sites in the Middle East. This site, this is variation, this is altitude, is the colors. So this is a place that has no variation in altitude, either within 5 kilometers or within 50 kilometers. So this is a place where, you want to become sedentary because you're not able to access any variation by being nomad, any extra variation by being nomad. While this is a place where you have a lot of variation close by, but you don't have any extra variation in a wider sense. Anything you can have within this extra location, you could also have here, because you both have the plain and the hill within this location. And if you look at this one, this is a place where there's no variation close by, so it's not a great place to become a settler, but there's a lot of variation further away. So this is a place where you definitely want to remain nomadic, because that way you can exploit this difference between this mountain and this plain, which you couldn't exploit any place by being settled. And finally, this is a situation where you have a lot of variation close by, but you have even more variation further away. Okay, so we call these two measures, the R5 is the range of elevations within 5 kilometers, and the R50 is the range of elevations within 50 kilometers. And the R5, the model predicts that places with a lot of R5, they should become sedentary early, because that means it's a great place to become sedentary because you already have different biomes close by. While if you have a lot of R50, then you don't want to become a settler, because by being a nomad, you can exploit all of these variation that you couldn't otherwise. Okay, and so this is R5 and this is R50. And these are the places that adopted earliest are in black, and the places that adopted last are in white. And so what you can see is that a lot of these places that adopted late, they might have a lot of variation close by, or they might have a lot of variation close by, or they might have little variation close by. But what they have in common is that they have a lot of variation further away. So they're great places to remain a nomad, because being nomad means that you can exploit, even when it's super hot or super cold or whatever it is, there's some place you can go to that's going to be different because it's a sheltered valley, for example. Or even if it's very dry, probably there's a very deep valley, and at the bottom of that, you can still find water. And if instead you look at the places that adopted very soon, what you tend to see, so it's this, all of these places are the ones that adopted soon, and they're the ones that have a very low R50. So they're the ones where there isn't really much of a reason to remain nomadic, because whatever you can access nomadically, you can also pretty much access by being a settler. So might as well be a settler so that you can store food. Okay, and so this is the regression. This is the years. This is how long ago people adopted agriculture. And what you see is that having agriculture close by, having variation in altitude close by makes you adopt earlier, while having variation in altitude further away makes you adopt later. And I struggle to see a reason why somebody would decide to become a farmer because there's a mountain 50 kilometers away, except for the fact that that mountain is something that they could exploit nomadically and not by becoming settled. So the fact that we see this pattern of agricultural adoption suggests that we have to look at the package, that the nomadism versus sedentism question was as important, if not more important, than whatever was going on with soil fertility or access to water in a specific place. That's just what comes out from the data. Now, the interesting thing is that if then you look at an even wider radius, if we look 200 kilometers away, which is too far even for most nomads before there's horses, then we see that it becomes irrelevant. And this is one of the things that really made me happy when I was doing this research, because it's effectively the same variable, except taking different bandwidths, and we get opposite results, and the results make intuitive sense with sort of what we know about how long people can walk in a given day, do some useful work and come back. Within 5 kilometers, it's pretty reasonable, and it has the expected sign. Within 50 kilometers, that's a reasonable migratory range for a nomad. And then as it gets unreasonable, then it just sort of disappears. Okay, and then the final, sorry, I'm a little bit over, but I do want to just do this one. The final piece of evidence is Harris lines. So these are lines that form in bones if there's a growth arrest episode. So if you're a kid, you're growing very fast and then you starve, then your growth stops. When it starts again, it's going to deposit, this is a cross-section of the same bone, it's going to deposit this thin line of bone that you can see in x-rays. So it's a little bit like a tree ring, except instead of getting one every year, you get one every time a child is starving. This is the bone from Inuit, the populations in Alaska. And they were starving every year, effectively for a period during every year. And so it looks a little bit like a tree because they're regularly spaced. And the important thing is that hunter-gatherers, they were taller, but they tended to have this pattern. They tended to have more Harris lines, and they tended to be regularly spaced. While the farmers, they're shorter, which means they're eating less on average, but they don't have this pattern, which suggests that they were able to smooth their consumption, which is also a prediction of my theory. So answering the 4 questions. So why didn't agriculture appear sooner? Because seasonality was globally low until about 12,000 years ago. Why did it appear in multiple locations at once? Because changes in Earth's orbit increased insolation seasonality worldwide, which created changes in the monsoon and changes in the seasons. And what did the locations where they had appeared have in common? What they had in common was that they were all exceptionally seasonal in either temperature or precipitation or both. And so why were the farmers shorter than their hunter-gatherer ancestors? They were shorter because they lost access to dispersed food sources, and the lack of seasonality let their numbers increase relative to the average amount of food they had. Okay, and as I think, I said, this is a theory that plays well with others, meaning that within this framework, there can be any given reason about religious beliefs, there can be any given species that was easy to domesticate. These are all things that can happen within this broader framework. It's a little bit, again, I like what I said about fire. You can ask, why is it that, what was the source of ignition? Many different sources of ignition, many different sources, many different paths to domestication. But why is it that, it spread so quickly with fire? Because it's dry, because there's wind. because it's hot. With agriculture, what made it spread so quickly and what made the adoption so enthusiastic is the fact that seasonality was globally very high. Okay, so we showed a model, I made some predictions, I tested them with data, and it seems to be true. One thing that sort of suggests is that the patterns of climatic seasonality 10,000 years ago played a very strong role in determining where farming first appeared, which crops were domesticated, and which ethnic and linguistic groups got a head start. And they're also where the earliest cities would rise. And another thing that for me sort of pointed out is that our ancestors abandoned a high payoff, high risk lifestyle for a low payoff, lower payoff, but lower risk one. And so we should remember that when we're close to the subsistence limit and we don't have insurance, then volatility is often more important than average outcomes. So also in a development context, if we want to tell people, well, why don't you load up on debt and buy fertilizer or whatever? We had a high risk. We had a high risk strategy already. We abandoned it because we wanted the sure thing. So if we think about development, we think, I mean, it's been said before, but it's just another reminder that when we think about development, we have to give people safety as well. Okay. So I mean, there's other things we could talk about, but I'd rather hear more questions and hear from Jed his discussion. So I'm going to close it here, and thank you so much.
Thank you, Andrea. So now let's turn to our discussion session before we turn to the Q&A. We are very happy to have Professor Jed Kaplan, Professor of Earth Science in Hong Kong U, to give a 10 to 15 minutes comment and discussion on Andrea's work. So Jed, please.
Great, thank you, Chi-Cheng, and thank you, Andrea, for the stimulating presentation. It's very interesting from my perspective, coming from paleoclimate and having spent many years working with archaeologists, to see an analysis of a long discussed and well thought out problem being approached by somebody from a completely different background. And so you have different tools, different methods, and different ideas for trying to develop theories. And so it's refreshing in a way because I think oftentimes in academia we get siloed into our own disciplines and into our own sort of echo chambers, talking to the same people, agreeing on the same theories and the same ideas. And it really takes somebody coming in at a topic you think you understand well, but coming at it from a completely different perspective to really challenge your ideas and challenge your paradigm and make you really think hard about why you believe what you believe. And I think this is a really classic example of that. The Neolithic Revolution is something that I have been working on for 15 years, and I kind of never thought about it in this way before. And so I was really kind of ruminating and stewing over your paper, sort of thinking, oh my gosh, this is just really something that this is talking about it in a way that I never thought of before. So thank you very much for that. I really appreciate that. I have a few points of reflection, and my thoughts are not as well organized as your presentation was, so you need to bear with me a little bit. I will throw out a bunch of questions. Maybe you make a few notes, and then you can go through them afterwards. And I am going to try to keep my comments to well under the time limit so that we can have a bit more interactive back and forth instead of me just sort of giving a one-way response to your presentation. So coming to your second or third slide, you sort of said, I'm going to address these questions. Why did agriculture not appear sooner? Why did it appear in multiple locations at once? And what were the locations and what do they have in common? So I just reflect on a few of those things. First of all, why didn't agriculture appear sooner? Well, there's evidence at least for pretty intensive horticulture and gathering all the way back to the last glacial maximum is the well-known site of Ohala 2, which is in the north of Israel, where you have at least some cereals that are on the pathway to domestication about 10,000 years before the first sort of agriculture in your, at least in your presentation, starts. So people are clearly well on their way towards agriculture thousands of years, if not 10,000 years before your posited origin of agriculture date. And so I think that there's the seasonality argument, while it is seductive, is maybe not a completely full treatment of what's actually going on, because we need to recognize that the process of intensification and domestication starts long before the beginning of the Holocene. Why did agriculture appear in multiple locations at once? Well, I guess I feel like it doesn't really occur in multiple locations at once. It really takes 6,000 to 7,000 years from the first agricultural origins to the latest domestication, although you could even argue that there are no more independent domestications occurring nowadays because everybody around the world knows about agriculture, but definitely
that was the interesting thing for me compared to the Industrial Revolution, is that it was slow enough that we can observe multiple ones. We don't know how long it would have taken India or South America or China to do the Industrial Revolution on their own, because it moved by ship and it got there in 20 years. And so that's it. That's why I found the Neolithic interesting. Sorry, please.
So it does actually occur. I mean, I guess my point here is that it does occur over a very long period of time. And so I'm also, not totally sold on the seasonality argument, because it's sort of that basically implies that you need to have some non-stationarity in this seasonality, that in certain places there was more seasonality early in the Holocene and other places later, and this starts to get a little bit complicated. What were the locations? What do they have in common? Well, there, I think I basically agree, and I really liked your sort of fine scale regional analysis of where agriculture originates, in particular in these very diverse and heterogeneous landscapes, as opposed to ones that were, say, out on flat ground surrounded by more flat ground. Okay, but I think that on the global scale, you miss something in the seasonality argument, and that is two of the principal centers of domestication that are missing from your analysis. One is in the highlands of New Guinea, which has basically neither temperature nor precipitation seasonality, and is well known to be a center of independent domestication. And the other one is in the lowlands of South America, and particularly in the Amazon, where most archaeobotanists nowadays would argue that there are at least several important crops like cassava that were domesticated in a landscape which is relatively certainly not seasonal in terms of temperature, and not really very seasonal in terms of precipitation either. So there's not a lot of evidence that this is a transmission of ideas, and so I don't want to accuse you of cherry picking, but I do think that there is some interesting outliers there that kind of would be interesting to explore. Another one is why didn't agriculture originate in Australia ever?
Oh,
right? And so wait, let me continue. Come back to that. So make a note. Australia has plenty of seasonality in its climate, particularly in rainfall, but also in temperature to some degree. And so I wonder what's going on there. I'd like to just kind of come. All right, two more points, then you can respond. One is Richardson suggests that agriculture is impossible during the last glacial period while it becomes obligatory in the Holocene. And I think that the second part of that statement is also supported by your research, that once society starts agriculture, it's more or less a one-way street. You can't actually give it up again. The first part of that is interesting, and I'm not necessarily, again, sold on the seasonality as being the key to that, but rather the intense variability in climate on decadal to centennial timescales. Any society that potentially could have started with agriculture during the last glacial cycle, and there's perhaps some tantalizing bits and pieces of evidence of at least horticulture that's occurring in the Southwest Asia during the last glaciation, couldn't have in the ideas of Richardson persisted, because after a few decades or a century, the Earth would have gone through massive and rapid climate changes, which would have forced people to effectively give up their agricultural livelihood in that place where they lived. They would have had to, not because they would have wanted to, but agriculture would have simply become completely impossible in places that went through, centuries of drought or freezing conditions or so on. Finally, I just like to, there's a really good paper. It's not cited in your paper, but I recommend having a read through it. And it's by Melinda Zader. It's from 2012, talking about the broad spectrum revolution. And I just want to quote from the conclusions of Zader's paper. Melinda Zader presents an alternative view that does not situate the broad spectrum revolution. And the broad spectrum revolution is basically the foundation of your hypothesis as well. The idea that the broad spectrum revolution, the origin of agriculture, starts in marginal or degraded environments, or in the context of threatened or real resource depression that forced hunter-gatherer groups to give up mobility and more profitable subsistence practices and settle down to a diminished lifestyle based on suboptimal resources that they had to work harder to procure and to process. Okay, so this is basically also what you're saying, and that is the broad spectrum revolution theory. Zader suggests instead that her alternative view sets the broad spectrum revolution within a context of environmental opportunity, where people were able to use their singular knowledge of the environment and their ingenuity in manipulating that environment to their benefit. And so Zader argues that it is not some kind of change in resource availability or stress placed on people through environmental change or climate change that stimulates people to start agriculture. What stimulates people to start agriculture is simply the fact that they live in these resource-rich environments where, when they are blessed, if you want, with a long period of stable climate, through their accumulated knowledge of that environment and gradual ability to transform it, what she calls ecosystem engineering or niche construction, that leads them towards agriculture. And so it has nothing to do with a kind of resource constraint, but is rather a familiarity with an environment that lasts for thousands of years, that brings people into a spontaneous agricultural origin. So I'll leave my comments with that. I'm very happy to hear your responses, and hopefully we'll get some good comments from the audience as well.
Thank you, Ted.
So for me, so the first thing with Ohalo 2, so as I mentioned in your presentation, like, it could very well be that there's Ohalo 2 is going back, as long as there's been humans. We haven't found them, but it could be that occasionally on some hills, some things happened, and some people would start on a path towards higher sedentism and starting towards farming. What is interesting for me, again, is sort of, the McDonald's franchising model. It's a bit like saying that actually somebody in 1722 had already made a hamburger. Well, in McDonald's, there's a hamburger, but there's also like another thing which is important, which is, a process for bringing that thing and bringing it to another place. And there's a manual and you can do it, and it's replicable, almost anywhere in the world. So for me, ohalo is like, okay, somebody was already putting some ground beef in between two slices of bread. I'm happy that they were. It's probably important even for the history of how McDonald's got to exist, but it's not what I'm interested in until you also have, the elements that make it portable. And what I think makes it portable is, let's say car culture in the case of McDonald's. So people needed fast food that they could get, whatever it is. I'm not an expert on that, but I'm saying there's some other situational aspects which makes something that had been smoldering over thousands of years explode really, really fast. And for me, this is what's interesting about the Neolithic, is the rapid spread of it. If it had stayed on some hill somewhere, who cares? Then in terms of like, is it at once or not? Okay, is 5,000 years, it's true that it's, 5 or maybe 7,000 years, depending if you take the extremes of the dates, of the range dates. But a lot of them are quite concentrated around 9,000. And also if you compare it to, there were people in sub-Saharan Africa for, 200,000 years. And for some reason, they had to wait until the bottom of South America was populated before they started considering this. So from my point of view, it's in the eye of the beholder. But if I planted a bunch of paintings and they were fine for 20 days, and then on one day they all fell together, I would think something was happening to the nails in my house. But I didn't do a systematic statistical analysis of whether the probability is changed. Now, in terms of like, why did I pick those 7? It's the one that I found the paper. Everybody has their own idea. I found this paper, Puruganan and Fuller, and those were the ones that they said everybody agreed on, and they had them on black in the map, and so those are the ones I used. And then I also use it with 24 other centers of domestication, including the highlands and including India, the Indus Valley culture, and including Papua New Guinea, and the results are more or less the same for Invention. It's also, those 7 places, it's always going to be the 7. I'm never going to convince anybody, even if I get all 7. It's only 7 observations or 9 observations or 24 observations. I just want to say I'm hitting like the main notes, and what I think gives me some degree, of confidence in saying that there's something there is all of the other evidence on the spread and the Harris lines and things that really nobody had really sort of focused on. And now for Australia is my favorite place in the world now. Not just Australia, but if you think about the Middle East, well, it could have happened in Australia, it could have happened in parts of Argentina, and it could have happened in parts of South Africa that looked, remarkably similar to some parts of the Middle East. Now, the reason why it didn't happen there is because they look very similar today with today's climate, now that Earth's axis is tilted the way it is. But they did not get this spike in seasonality that happened in the Northern Hemisphere, because the Northern Hemisphere was pointed towards the sun at the time when we were also at perihelion, so when we're closer to the sun. Those effects were working in the opposite direction in the Southern Hemisphere. So as the Northern Hemisphere was getting the spike in volatility and also the monsoon areas, the temperate regions of the Southern Hemisphere were actually experiencing a seasonality minimum. So actually Australia, South Africa, Argentina, these are places that, it's like, thank you for bringing it up. I should have brought it up in the presentation. Now, in terms of the Melinda's error, the broad spectrum synthesis, is it a challenge or is it an opportunity? And obviously it's the difference between the two. It's, how good is my one thing versus the other thing. And I think in a sense, it's kind of like that my paper is the synthesis of the two, because it's saying there's this opportunity of this phenomenal northern, just a second, because there's 2 kids that are, okay. No, I have 2 kids that are sick, and I have to monitor the situation. No, they have a flu, but there's some families. Okay, so there's 2 situations that are. There's this summer, which is this fantastic opportunity. Nothing is as productive as the northern hemisphere summer in a place that has decent rainfall. It's phenomenal. But you have also this problem, which is this winter, which is just abysmal. And so how can you take advantage of this phenomenal opportunity and all of this knowledge that you could have of these places? And how could you apply it to this fantastically productive summer, but still survive the winter? and it's really storage which allows them to square the circle, and it's storage that allows them to square the circle and eventually progress to agriculture. So those would be sort of my responses to those points. And now I have time for a couple of questions, but I have to finish at like 1/2 on the dot.
All
Okay,
right,
so
I'll leave it for the others then.
Sorry,
Well, I think
I'm
we'll have
sorry,
to agree to disagree, but that's all right. Perhaps we can pick this up another time.
Absolutely, I'd love to talk, when the kids are in school.
okay, now let's go over the question from the audience.
Yeah.
I would like to begin with our colleague and friend, Professor David Mars, a very interesting question. He asked, hunter-gatherers eat more meat and drink more milk than farmers, and that's why they are taller. Is that right?
Yeah, no, so they don't drink so much more milk because they don't, there's not only so much milk in an animal when you kill it. They haven't domesticated it yet, but they are eating more milk. But one of the things that's interesting is that the Natufian population, which is this transitional group, which is already sedentary, but still a hunter-gatherer, and they're already relying on grains to some extent, but they're also hunting a whole lot. And this is the population that gets shorter. They don't get shorter when they start farming. They get shorter when they get sedentary and they start storing. Even, in a lot of agricultural societies, there is some reliance on game and there is some reliance on sort of animals. And I forget when it is that they domesticate animals in this season, but it's not necessarily, again, when people hear hunter-gatherers, they focus only on the hunter. But it's a hunter-gatherer, and they're relying on plants and animals as well. And some groups of hunter-gatherers are relying on plants to a very large extent indeed. Now, the place where milk becomes important, I think, is with the spread, because the question, if you're a farmer, is if I want to create a new colony, what do I eat that first year before my crop comes in? So having milk, having cows, means that you can, grow the cows, and then you can drive the cows to your new place, and then you can milk them and you can eat the cows as you're preparing your settlement. And this is, I think, why Europeans are famously lactose tolerant. And I think it was really related to the spread. This is kind of a theory. I haven't tested it to the same extent I have the others. But to me, the fact that there is this rapid spread, it makes it a lot easier if you have cows, which you can bring your food with you. Your food follows you around. That's very convenient if you're planning on, populating a continent at about, a mile a year or something like that.
Okay.
Other questions, sorry?
So the remaining two questions are from Alexander Coach. The first is a comment, actually. There's also early rice domestication in South America and around 5 Ka. So let's go to his question. I think this question about the method. In your OLS regression, with year and outcome, and which time and what time are the covariates measured? Here, I think, for example, a Cox proportional hazard model would be more appropriate. In your logic regression, you should test the marginal effects for statistical significance rather than the logic coefficients. Marginal effects are also more informative.
Yes, so I did it within a couple of different ways. In some regressions, I'm using, because it's at risk at that moment, I'm using the instantaneous seasonality. And in some of them, I collapse everything to just a cell. So the time, each observation has the number of years that pass before they adopt. So sometimes I'm using the instantaneous climatic variables, and sometimes I'm just using the average throughout the period. In practice, it's one of those things where, I tried them and then I do whatever the referee asks because they all worked. So, whatever they want goes. But actually, one of the referees did ask for the Cox proportional hazard model. I think I have it in an appendix now, but I'd love to talk to Alexander more about this because, I'm kind of more of a, geeking out on the Neolithic thing and figuring out the logistics of it than necessarily, you know, the subtle points of which when you should use different proportional hazard models. I'm sorry, now I have to relieve some family members that are caring after some kids that are unhappy with their current cough. So thank you so much for having me, and thank you for the question, and thank you, Jed, for the comments. I think we should talk more about this. And again, thank you for having me. It was
Thank you, Andrew.
super fun. Thank you. Bye bye.
Thank you so much.
Andrea.
Bye bye.
Mm.
Mm.